It's a great pleasure to present, thank you, Steve, at this conference, and it's a great gathering. And I thank Steve and John because I feel the fire, again. The Auto ID Center went through a period of similar ignition, and it was fascinating. It was kind of like, a petri dish where things, new life forms were being born. And then we moved into the execution phase, and EPC Global, of whom there are many representatives here, started executing. And meanwhile, the Auto ID Lab, refocuses its attentions on new research. And we have a family of Auto ID Lab members, professors, students, colleagues here, who've kind of recreated this entire environment. And Elgar Fleisch and Jun Murai and John Williams and Peter Cole, of course, who's been involved with this for a long time, Dan Ingalls. It's fantastic to see this all come together again. It's a great pleasure. It's almost like, I keep saying this every time I go to a Auto ID event, it's like a wedding, It's like going back to a family wedding and recognizing all your friends. So it's a great pleasure. What I thought I would do is talk about the future as I see it. And actually, funnily enough, I didn't have to change my slides from about 7 years ago. And just paint a landscape of what it is that academics can do research. And I should tell you a little story. When I started this research 7 or 8 years ago, David Brock and I actually David Brock gets a lot of credit for this. I wasn't sure that, I was coming up for 10 years. I was trying to write papers and make an academic field out of this. As many of my former students sitting here will tell you, I wasn't sure this would be a tenurable topic. Could I write papers? Could this be academic? Is there some real research here? Or am I just slapping tags on things and, reading them and feeling good about it, right? And has all the technology development been done? We as a group grabbed the tiger by the tail, and the tiger took us to places that we didn't discover, we didn't know that it even existed, And what I discovered in that process, and perhaps this applies to other technologies as well, is I think one needs to understand that in any new technology, and especially in RFID, there are embedded layers of richness that are revealed as you start making things practical. And the beauty is that they come in different colors. It could be in security, it could be in protocols. There's so many areas of richness that are waiting to be explored. That's the first thing. And the second point I want to make was that we are very much at the beginning of the journey, and that's kind of where I'll start. So there is a lot of self-satisfaction, which is, I think, in some ways deserved, that, we're there, let's start doing it. And that's great. We should be doing it. But I have to say that we're very much at the beginning of this journey. Thank you. I'll just put you. We're very much at the beginning of this journey. RFID has been around for 50 years, and the Auto ID Center is only 8 years old. But it would be very arrogant for anyone to suggest that somehow the research has been done. There's just so much exciting stuff to be done. And, if you look at the history, right, the first papers in this, and I did a reference search. By the way, there's a wonderful paper called The Shrouds of Time, The History of RFID by Lant. It was published as an AIM publication. If you do a search on Google, you will find it. It captures the history very well. But if you do a reference search, the first papers came out in 1948. Peter Cole, who's sitting right up front here, was involved with many of the early implementations of RFID. And in the 70s, automotive license plates. Is that about right, Peter? Is that about the first reference? Began to appear. And then RFID went into this highly kind of specialized research phase. We, as a center, started in 1998. And then we developed standards in 2001. We couldn't get the rest of the industry to really join us, so we bucked the trend and developed our own protocols with some innovative startup companies like Alien Technology and Matrix, and those were the Gen 1 protocols. And that's how we started getting the industry going. But the reason I'm putting that up there is that's, 2000s. This is 2006. It's not that long ago. And it would be very arrogant for any of us to suggest that somehow in 5 or 6 years we figured out everything that one needs to know about RFID. And the first bulk tagging is only a year old, folks. Really, it's only 1 year old. The first mandate really hit in early 2005. Here we are in January 2006. So there's a heck of a lot of work waiting to be done. And what I did 7 or 8 years ago is I created a landscape. I looked at every research topic I could possibly do in RFID, because remember I was trying to get tenure, write papers, and I wanted to create a landscape. And actually, that hasn't fleshed out very much. So I'll put that up now, and I'll use that as a theme for the rest of my talk. You can break it up in many ways. You can look at technology. And the beauty of RFID is it spans everything from semiconductor manufacturing to systems research and distributed discovery and things like that. So you have tags, you have semiconductors, you have antennae on tags, you have material constants, you have material properties, you have the interconnect between the chip and an antenna by itself is a significant PhD thesis waiting to happen, right? Just that, right? You have packaging off the tag. You have, how does the tag deal with, reactor packaging? We had a wonderful project here that Dan Engels led on tag packaging and performance. You have protocols. Of course, this the Auto ID Center did a lot of, and there are a lot of experts here on tag protocols. We're barely scratching the surface of protocols. We have Gen 1, which is Gen 1 UHF. We have some HF. Now we have Gen 2. But then there's ultra-wideband. There's all sorts of interesting stuff just waiting to be done. I'll touch upon it in the next few slides. You have reader antennae. Think about this. Everyone thinks of that. I should say there's a lot of thought that perhaps, antennae are not that interesting. Maybe there's not so much research there. But think about it. You have miles and miles and miles of store shelves. How on earth are you going to read all the stuff on those shelves? Now, initially, people are looking at portal-based solutions. You put readers in doors. But eventually, you're going to want to get real-time inventory, not based on transit, but on a real integrated measure, that is a measure of actual inventory. How are you going to put readers on these things? Is it going to be cheap antennae which multiplex using some sort of printed ink multiplexing over a cheap wireless to a reader? Is that what's going to happen? Or are we going to invest? Then how do you power, if you put readers everywhere, how do you power them, right? If you walk into a retail store and you see a display of clothes, you will find that the clothes sometimes are right in the middle of the floor. How do you power them? Is it a battery? Or do you need to run wiring underneath? Such mundane problems. Power over Ethernet is a hot topic these days. Is that the solution? I'm sure there are a ton of other solutions we haven't even explored. And there's a tendency to kind of take the cliched solution where something very innovative and probably game-changing is just lurking around the corner. So there's some very interesting technologies just in these 4 topics waiting to be researched. And then there's readers. We predicted some 8 years ago that readers would eventually be very inexpensive, hundreds of bucks. They're down to $1,000 now, but there's a long way to go. And the fact of the matter is the electronics in readers is not that complicated. So we have a lot of advancement. Then there's middleware, there's software, there's the actual middleware. One of the problems with RFID is that there's a tendency to believe that RFID tags will be read in the same way that barcodes will be. That is, you read the barcode, you know exactly what's there, and you're done. The fact of the matter is, the whole point of RFID is you're reading all the time, and you're going to miss a few. And missing reads results in phantom inventory, especially when you have a throughput model, where you look at things going in and out, right? It results in negative and positive phantom inventory. And phantom inventory is going to completely jam up any inventory control system, any application that you develop. So for example, let's say we all had tags, and God forbid there was a fire, and we all went out, and there were readers at the doors. And the readers at the doors missed a few of us. This room would legitimately claim that those of us that didn't get read are still in this room. And it might send a fireman into this room looking for those people that the reader missed. Now you can see right away, now that's a dramatic example, but you can see right away that when you're doing inventory control, how terribly that could send an inventory control system out of control, right? How do you manage things like that? Well, you know what? Maybe there's a reader on the way out, and that picked me up. So you can say, listen, although this reader didn't pick me up, a later reader saw me, so let's correct inventory here. That's a very deep database concept, all right? It's kind of a generalized predicate of consistency that you need to superimpose on top of a database to make sure that your data is consistent. Right there is a research topic just waiting for someone to look into. And then there's databases, there's streaming data, right? Fast and furious. How do you do joins on streaming data? There's actually a lot of research in various computer science departments on that. There's enterprise architecture. Is this going to fundamentally change the way in which we do enterprise architecture? The world is built around databases today. Will we go to fundamentally a new enterprise architecture? My own feeling is about 10 years we'll be in a completely different way of thinking about enterprise software systems based completely on events as opposed to based on databases. That's my view. But I may be wrong. And then there are distributed systems, discovery. We developed something called the object name system. If you're familiar with it, it's just a way to find the company that owns a particular EPC. That was a drop in the bucket. Already we are seeing that is useful, but it's 1% of the way to everything you need to do to really take advantage of RFID, right? I can say that because I was one of the people who wrote on it, so I can criticize it. But I think it's very important for an academic community to focus a microscope and critique these things and start improving on them. And it's just waiting to happen. Is it going to be, I don't know, the semantic web? What's it going to be, right? Well, you need to look at that. Identity management, what's going to happen when you have hundreds and hundreds of companies trying to access data? How do you manage identity? Is it going to be using Microsoft Passport? Is it going to be using something else, right? What are the standards there? Is it going to be federated? Fascinating tens and hundreds of research topics waiting here. The problem will lie in making sure that these research projects solve the question with a clear understanding of the application. And that is why I think this conference is perfectly timed, because the industry is finally looking at this very seriously. You know, Mike Rose of J&J, we were just having breakfast this morning, and we were talking about, you know, how the industry really is struggling with some serious problems. And, you know, they have some experts, and they're academic experts, and finally now there can be a real conversation. When we were doing this a few years ago, we were making stuff up and projecting on industry and hoping we were right. And by luck, dumb luck in many ways, right, we were kind of right. And we had great guidance from the early sponsors, the Gillettes, the J&Js, the Walmarts, et cetera, Targets, right? But now is the time to have a very high bandwidth conversation. And finally, by the way, I think that RFID is going to change the way our business processes work. It's going to change the way that you go into a store and you interact with the store. It's going to change the way a store is operated. The machinery is going to change. And that, to me, is a technology. It's not business. It's a technology. And that's going to be the most fascinating part of all this. You can look at applications. You know, most of the attention's been on supply chain, but supply chain is barely a start. You know, we talk about retail, healthcare, business to business, critical goods. We just went through Katrina in the U.S. and the tsunami and the earthquake in Pakistan. What happens when the next disaster occurs? How do we make sure that we route blood correctly? How do we make sure that if there's a bird flu episode somewhere in some town somewhere, that we route flu vaccines or Tamiflu correctly? These are all, again, very fundamental opportunities for RFID, and it behooves us to start dealing with these things in a scientific way instead of the very, really ancient approaches we're taking to disaster recovery. With RFID, we should be able to kind of run, you know, you should have a map. It's like a weather map of the disaster and where your various, you know, resources are and how do you map them and, you know, what you need where. Well, here's where the flooding is. We need to send certain equipment here. Here's where there's a disease outbreak. We need to send something here. We should be able to do this in a much more scientific way. And visibility is key. Steve talked about the aircraft industry. And what's happening there is the aircraft industry, which has historically been very inefficient. I happen to have studied that in a past life, is, again, waiting for a fundamentally new efficient model. Boeing and Airbus cannot survive the way they have survived with gigantic government subsidies at some level or the other, right? And they have done the right thing, and they're trying to re-engineer their supply chains. It's very different than even the automotive supply chain because the lots are much smaller and the products are much fewer, and they can get a lot more flexibility. And I think that's a great new opportunity to use RFID to get visibility through just-in-time manufacturing, delivery, et cetera. So again, for people who do operations research, Tully, right, fantastic opportunity there. Now, if you look at just operations, factory operations, Airbus and Boeing are going to do it. DC operations, Brian Subarana, who's there right there, right, spent a lot of time with Gillette looking at their DC operations. And it's such a, you know, when we started that research, we thought, is this boring? I mean, are we going to find something here? But when you actually get into it, it's fascinating. You start peeling the onion, and you find that there's so many opportunities to make DCs, this boring, dusty, you know, box of a building, exciting, faster, more efficient, less error-prone, and fundamentally, you can start reducing inventories, right? And of course, you can look at institutions, hospitals, hospital operations, a huge opportunity, right? There are several PhD theses probably in looking at the logistics of hospitals. Drug delivery, missed prescriptions in hospitals. I'll talk about that in a second. Personal systems, you know. So I can barely scratch the surface of applications. And then finally, the kind of the million-dollar question for an academic is, so what's the analysis? Where are my equations? This is all fine, right? But where are my equations? Can I write an IEEE journal or an ACM paper on this vie for the next Turing Award? I actually fundamentally think yes. There are some fundamental intellectual opportunities at every level. Everything from RF systems and communications. Many years ago, I was sitting down with Peter, and I said, Peter, what is the fundamental difference between RFID and other communication systems? And he summarized it to me. It is that in RFID, unlike in other communication systems, the bandwidths and the power are just very different in two directions. And you want to design protocols that work in these asymmetric channels. It's just very different. All right? Computing cycles, I'll talk about that, are expensive. Communication theory, very interesting, right? All the communication theory, error correcting codes, all the stuff doesn't necessarily map to RFID because RFID is so different. System dynamics, security, I won't belabor it. Beautiful, challenging, frustrating, exciting problems wait to be attacked. And it's great to have this community come together and try and think about them. The thing that makes RFID special is everything is different. Everything about RFID is different, right? First of all, power is limited. So range is limited, right? You can't compute because every compute cycle sucks up power. You can't put a lot of memory because every piece of memory increases cost and power. Cost is an issue. So you're kind of boxed in. So it's kind of like, you have very little wiggle room, but yet you're trying to do everything. Now you add to that, bandwidth is limited because you're always operating in industrial, scientific, medical bands or some free band. At least the general RFID movement is always going to be in a free band, so bandwidth is very limited. You can't do much with this stuff. Memory is at a premium, as we discovered at the Auto ID Center. You get a lot of data from RFID tags, but it's very fallible. In other words, there can be a lot of wrong data. Like, as I said, it's not wrong in the sense that the read is wrong, but the false negatives, that is a misread, can manifest itself in ways that can screw up your typical algorithm, right? So you've got to correct for that. Here's a very interesting one. Tag connectivity is sporadic. That's a very subtle one. Even my cell phone, right? Let us say that Singular Wireless decides that it wants to upgrade the firmware on my cell phone. It can kind of do it because it's got, 80% of the time it's on. With an RFID tag, you don't know where you're going to see it next. Let's say you wanted to, write some data to it. You don't know where you're going to see it next. It could be in your company. It could be at MIT. It could be at P&G. It could be at Walmart. You don't know when you're going to see it. So what are you going to do? Pre-position all that information in every reader on the planet that you want to put on that tag? Well, you couldn't possibly do that either. So there's some compromise where you kind of know where stuff is, and you think you're going to see it there, and you push the information there in the hope that when it shows up, you can push that information down. That's just a fundamental distributed computing challenge of extremely irritating but yet interesting magnitude, right? So tag connectivity being sporadic kind of compounds everything. And to add to everything, cell phones are targeting a human being carrying this thing and holding it to their ear. That's it. Tags can show up on products. They can show up on animals, right? They can show up on pallets. They can show up on metal containers. They can show up inside metal containers, right? They can have sensors on them. They could be active. They could be passive. So you've got to prepare for everything. So if you have a reader here, it's got to be ready to read that passive tag sitting right there, and possibly an active tag with a 1 kilometer radius, which happens to be in the next building, and make sense out of it. It's fascinating to think about it. And these are problems that people are facing today. These are not problems I just made up. This is just beginning to happen in real life, right? And finally, the range of technologies is huge. You will have active tags, passive tags. You're going to have GPS, right? How do you integrate GPS with these systems? Actually, by the way, it's not bad news. It's all good news, and there's already people are doing these things. But there is no cohesive, overarching thinking pulling it all together. You have cellular technology, readers inside cell phones, right? Fascinating. So what I thought I would do is I'll take this map. It's kind of like looking at the planet and spend, I don't have very much time, but I'd like to burrow down in a few places and just give you a taste of some of the research that the Auto ID Center did, other people did, and see how, I want to show, if you haven't seen this, give you a sense of how rich it can get, how quickly it can get rich when you burrow down. So I picked, when I was making these slides, I created this landscape, and I said, let's look at protocols. Let's look at RFID protocols. How rich can that really be, right? It was a question I asked myself in 1998 when I was deciding with David Brock to get into this research topic. Could I write a paper here, right? What I can tell you now is there are probably 1 million papers there. At that time, I thought there was 0, right? So when you get into it, so let's zoom in. What's protocols? Well, it turns out protocols are not just protocols. There's a physical layer, and there's a logical layer. In the physical layer, there are different frequencies to consider. There are different schemes, like ultra-wideband, that are popping up to consider. Okay, well, that's pretty good, right? And then there's a logical layer. In the logical layer, you need to look at readers interfering with each other. Dan Engels and I wrote a paper in 1999, I think, on readers interfering. And we thought it was just pie in the sky, just an intellectual problem we invented. Turns out it's actually a very serious problem, right? So you need to make sure that readers don't interfere. And there are a couple of ways to do that. You can do something called tag sessions, which actually is in the Gen 2 protocol. And you can do something called in-band reader coordination, which we couldn't get into the Gen 2 protocol. But there are other reasons for that as well. There are technical challenges that need to be addressed to do that. There's security, right? How do you make sure that privacy is protected? Someone can't eavesdrop on targets, reads, and make sure that, and see what inventory they've purchased so they can game them, right? There's different data types. There's the EPC. There might be sensor data. Then there's sensors. How do you make sure when you read a tag, let's say if it has a sensor, that you know it was a temperature sensor, that the data is that, follows the EPC? Well, okay, the temperature that is reported, is it in Celsius or is it in Fahrenheit? Is it a time series or is it the temperature taken at that moment? If it's a time series, what units are we using for time? Is it compressed? Then what's a compression algorithm? Right? Isn't that incredible? I mean, just that question, you can go on and on. Well, if you're going to compress it, what's the cheapest compression algorithm you can put on a low-cost chip, which has very little power, very little bandwidth, right, and very little memory, and very little computing power? So, okay, so there are a lot of things there. So let's focus on a little more. So suddenly, protocols is a very rich topic. All right, let's focus on a little more. Let's look at just security. Just security. So this happened to me in 2001 or 2002. Was it 2002 when I gave a talk in Ron Rivest's group? He's a professor here. He's one of the security gurus at MIT. And I went and gave a talk there about RFID and some early thinking on security. So we dived into it. All right, so let's look at security a little deeper. Well, that's not good enough. Well, if you get into security, there are layers upon layers there. There's reader-to-tag security, making sure that the reader-to-tag communication is made secure, and we'll expand upon that. There's making sure the middleware is secure. That is, that the middleware talks to the reader in a way that is secure, especially if it's wireless. There's security between the middleware and applications, SAP, bound, whatever it is. There's intercorporation security, right? Let us say that you have a fridge at home that's reading tags inside the fridge, and someone is sitting outside looking at your ONS hits. They can figure out, Sriram, he likes margarine, right? Maybe you're worried about that, right? So that is a very rich problem. Okay, that's getting too broad. So, now we're 2 levels down, folks. All right, let's go. So that's too much. Let's look at reader tag security. Guess what? That gets very interesting too. Now we're 3 levels down, right? And I thought there wasn't a paper there in 2001. Well, there's authenticating the tag. What's that? Authenticating the tag is making sure that the tag you read is not a spoof tag. It is that very tag that J&J put on a J&J product so that you can prevent counterfeits. And that has fundamental business benefits, health benefits, social benefits. There's authenticating the reader, which is the tag doesn't respond to a reader if it's not the right reader. That's privacy, right? The cheaper tags, passive tags, the whole privacy discussion arose because the tag is promiscuous. Any reader can read it. So if I have a bottle of some medication in my pocket, Trevor could come and read it. And I certainly don't want Trevor to know what medication I have in my pocket, right? But if the tag says I will only respond to a reader that belongs to anyone but Trevor, I'm sorry, Trevor, right? Then I am protecting my privacy from Trevor, right? So there's authenticating the reader. Then I need to prevent eavesdropping, which is all right, the reader and tag authenticate each other. I want to make sure a third party can't listen in and figure out what inventories in Target's warehouse. Oh, Target's running a back-to-school promotion. I can see that. I'm, at Staples. I'm going to compete with them. Right? They're going, a week early this year. So I'm going to go a week earlier. That's actually a big deal for these guys, right? There's preventing tracking, which is making sure that I don't know by putting readers at every T station in Boston, where, X's, girlfriend or boyfriend lives, right? And then how do you personalize everything? When I buy socks and take them home, how do I make sure that only my reader can read my socks and my medicines? And if someone else tries to read them, these are personalized. Even the maker of the product couldn't read them anymore. That's getting rich, right? So now we're 3 levels down. And again, it's turned to a really complex problem, right? And, just for the flavor of it, let's brainstorm. It actually gets very complicated. My initial guess, I had a student called Joe Foley. We said, let's just encrypt the number on the tag, privacy will be taken care of. No. If you just encrypt the number on the tag and put it on the tag, yeah, I can't tell that you have, Gucci shoes on, but I know the number. Are they Gucci, buddy? No. I know the number. And, no. I know the number, and I can still track you. So it didn't actually solve the privacy problem. It solved the privacy of the shoes. It didn't solve Bernie's privacy problem, right? Not that easy, right? So that doesn't solve the problem. Okay, then we thought, we got it. Let's just kill the serial number. All right, so I don't know it's that particular pair of Gucci shoes. I know it's a pair of Gucci shoes, right? And a lot of people wear Gucci shoes. So it's okay. But you know what? Bernie also has a Rolex pen in his pocket, I believe. And he may be the only person in Boston with high probability who has both Gucci shoes and a Rolex pen. So by constellation tracking, I know him and I can track him. And maybe you add to that, some particular brand of jacket. That's it, or triangulate it. So again, I haven't solved the problem, right? I'm just trying to give you a sense of it. Tough problem, folks. We thought we had it. Wrong, right? And you get deeper and deeper, right? And then you insist that tag needs to know the reader. Well, that means that the tag needs to have the password of every reader? Well, that's not a cheap tag, right? So, I won't belabor everything, but it just turns into such an interesting problem. Preventing counterfeits, right? This traditional encryption is expensive. There's challenge response. That means you need to put secrets on every tag. Very rich, very rich. Just waiting for someone to go nail these problems. Now, these we've looked at, and then we want to prevent eavesdropping. Many of these things we've kind of solved, but here's the secret, right? Actually, we've solved some of these problems individually. We have not solved the bigger problem of addressing all these questions. We just haven't. And right there, it's just a huge research topic waiting to be addressed. And for what it's worth, Steve Weiss wrote a beautiful master's thesis on this, in which he provides some solutions, and he very explicitly lists out the things we couldn't solve. But that's a start, right? So that's a master's thesis that came out of one talk where I was pretty much saying there's not much research here, right? And all that master's thesis, great thesis did was solve a couple of subparts and list out about 10 other problems that we didn't solve. Okay? So let's zoom back up. That was protocols, right? One of 30 things I've listed here. And you can look at everything. Retail, right? What are the opportunities in retail? Okay, let's zoom in, right? Retail, what is retail really? What is the retail supply chain? The retail supply chain is a very interesting thing. Toothbrushes are made in units of one. You make one toothbrush at a time, okay? What happens in the retail supply chain is you make one toothbrush at a time. You assemble toothbrushes into cases. So you have, say, 6 toothbrushes in a case. You put cases together. You make a pallet. You take pallets together. You make a container. You assemble them up so that you can ship them together. All right? So this is what the supply chain is. Then you move them. You sort them. And you repeat until the end. Aggregate, sort, transfer. Aggregate, deaggregate, sort, transfer. And that's basically what the supply chain. It's a big mixing thing where you make things as one, but all of the same kind, and that's a manufacturer. And people walk out with ones, but all of a different kind, and that's the consumer. And trying to do that efficiently is the supply chain in the retail world as we know it, right? This is another fascinating research area, and this is the one where the industry has focused its attention most immediately, because you're trying to do this in a timely fashion with very few errors and very little shrinkage. Well, if you actually look at it in real life, it turns out that that process is ridden with errors, too much, that's excess, inefficiencies, losses, right? Dilution, counterfeit, brand dilution. It's just incredible. I mean, we waste, and you know, you can look at the actual numbers that come out. We carry something like 30, 40% of inventory we shouldn't be carrying. For all that, we are 10% out of stock as an industry, right? And there's some fundamental research topics here waiting to be addressed. And whether they end up being looked at by companies, whether they end up being looked at by academics, right? The fact of the matter is that these are rich research topics waiting for academics to look at. Now, I'll say this. You can actually map the space out in many ways. You can take, for example, the supply chain, DC to backroom, backroom to sales flow to storage. And you can look at different parameters. You can get time, quantities, configuration. And if you map it out that way, in the interest of speed, I'll just write it out. I don't expect everyone to see this. But all I'm saying is, right there in that matrix, I've captured probably about 70% of the problems that most retailers are looking at. They're looking at, is my fresh food arriving in a timely fashion at the fresh food counter so that when my consumer buys that lettuce, it is fresh? If not, where is it losing its freshness? Maybe it's spending too much time in a DC. Maybe it's spending too much time in a truck. Maybe it's not cold enough in the truck, and so it's losing freshness. And what RFID lets you do is it's kind of like injecting a dye into your bloodstream and looking to see how the body is operating. And it lets you kind of go through all that and figure out how your body is doing. And if you look at different retailers, look at, for example, Walmart. This is publicly what they've said they're doing. If you look at Best Buy, this is what they're going after first. If you look at Lowe's, Lowe's is the big do-it-yourself store. This is what they're going after. So everyone's looking at it differently and going after different pieces of the puzzle. I have, lots of examples. I mean, I kind of zoom in and look at various examples. And in this audience are hundreds of other examples where you zoom into this landscape. It's kind of like using Google Earth, seeing something interesting and kind of zooming in, looking at a map, zooming in, looking at a house, You can do that. And I think fundamentally this is what this industry needs. And academics are the microscopes. And they're going to figure out what the opportunities are and figure out what the solutions are. In the interest of time, what I'm going to do is I'm going to skip over most of what I wanted to say, except this one slide. And say make two statements and end in about 1 or 2 minutes. When you have operations, for example, actually, if you can ignore the slide for a second, if you look at factory operations, you expect performance to be tight. When you say, listen, Father's Day is coming around, I want to move inventory out to the store, shaving blades for Father's Day because there's a big, gift buying event. I want to move it out 2 weeks before Father's Day, and then I'll start advertising on TV. I'm going to spend millions of dollars. You expect that things will work out quite well, right? People will move stuff out. The retail supply chain is going to kind of operate as you expected it, and things will happen as you expected. You can run your ads and get you're going to get good efficiency. The fact of the matter is that in many systems where lots of human beings are involved, and retail is one place and hospitals are another place, if you thought that the performance you would get would be like that is the bulk of the product would be moved out on the day that you expected it to be moved out, you're in for a disappointment. Because really, in most supply chains, performance is, unfortunately, despite the best effort, and we're talking about the top corporations on the planet, very loose, right? If you're familiar with statistical process control, the 6 sigma variation, the coefficient of performance of execution in most supply chains, in many endeavors where RFID would be useful, is rather poor. In fact, the coefficient of performance for a promotion that I looked at recently is something like 0.1, where it should really be 1.3. Okay? So if you understand what statistical process control is, just a metric, I can tell you in a very succinct way, there is a whole lot of room for improvement in the supply chain to make it tighter. And that's why people are looking at the supply chain. I'll end with this slide. Again, I just want to point to the bottom right. There's also a lot of exciting stuff on how RFID might fundamentally change the supply chain. And that's in some ways the most exciting part of all this, right? Is it going to change, is it going to make some macroeconomic changes to the way we operate as an economy, right? Now that's getting a little highfalutin and maybe getting a little beyond ourselves. But this is academics, you know? This is what we should be doing. So I just want to say, let's fantasize a little bit. The opportunities are vast, but perhaps, perhaps we need to start also thinking kind of at an aggregate level. Will retailers finally say that, listen, with RFID, we own our own supply chains. We don't need them anymore because it's not competitive advantage anymore. Maybe Walmart essentially becomes, as many of you know this, essentially just real estate with the Walmart name on it, or Target name on it. And all they do is they own the shelves and the product's there. It's like Amazon, and you go buy it. But it's completely up to the supplier to stock these shelves. That's called paper scan, for those of you who are familiar with this. Maybe that's what will happen, right? Maybe what will happen is the supply chain goes away and UPS takes over the world, or Federal Express. And essentially, manufacturers, FedEx or UPS, they stuff straight to the shelf. That's it. Who knows? Right? Certainly worth kind of gaming this. And if this community doesn't, who's going to game it? Right? In fact, Brian and I were fantasizing about that, and we call it the ultimately fragmented supply chain. Maybe that's where it'll go, right? Maybe, in the end, this might change the way offshoring is working today. You know, if you're familiar with the Zara supply chain, Zara is a Spanish retailer. What they do is that they're very tight in terms of fashion cycles. So every time, you know, I suppose Britney Spears has a concert, within a week, they have those exact clothes on the market for 2 weeks, and then they're gone. So if you go to Zara, right, you get exactly what you want right there, and because it's so fashionable and they're so agile, very few other retailers are able to compete. But the only way they can do that is not by manufacturing in Asia, because the lead times are too long, but by manufacturing locally, right? Maybe with the visibility RFID enables, maybe a lot of retailers can do this sort of thing more efficiently, and maybe it's going to impact the way we do offshoring. You know, we worried in this country about offshoring, I'm sure in other countries as well. Maybe some tectonic changes are awaiting us in the supply chain. And how will RFID play into that? I think it's worth discussing that. So I'll conclude simply by saying that, you know, obviously the first place this technology is going to make an impact is by tweaking things the way they're done today. Eventually there might be some evolution, but fundamentally there's going to be transformation. And it's the right end of the spectrum, the stuff to the right, that this community and no other community will be able to study and enable. And it's a great pleasure to address you and fantasize, but also look forward to talking to you about this, and have a wonderful conference. And thanks for letting me subject you to my crazy thoughts. Thank you.
So maybe a couple questions for Sanjay while we set up the next panel. Any questions?
Yes, one. So there's 1 million papers to be written.
Yeah.
How many need to be written before the diffusion curve starts to take off?
Yeah, that's a great question. I think that I don't know. I mean, you know, I think that in every topic, there's a kind of, every new area, there's a time of freshness where the papers are fresh and different, and pretty soon they start kind of grinding and, you know, into each other. It's kind of repetitive, right? I think we have ways to go. You know, if you take wireless, you take the internet, you know, take Google, right? Google is a research project out of Stanford, right? We're 15 years into it. Take the internet, we're 40 years into it, right? I think we have ways to go, but there's no doubt that's going to set in. I think we need to be watchful of that as well, right? So I agree. So we'll balloon, but then eventually we'll kind of kill ourselves and let it narrow. So that's a great question. Mark.
Part of the goal of this gathering was to try to bring together end users and researchers. So the end users are researching based on the researchers are doing their work based on MUP. How do we facilitate that communication so that the research is being driven in the direction the business is going?
I think it's a great question. When we started the Auto ID Center, we basically made some stuff up, right? And we went and just evangelized it, and we were lucky. We had some key end users involved in the very beginning. So we weren't completely, you know, making stuff up. We had some directed things we were, you know, going after. And we were kind of right. It's lucky, right? But we can't afford to wait on luck in the future. The good news now is the end users really get this. In fact, in many ways, they get it more than the larger academic community, right? And we have a lot of end users here. So I think that it's right, the time is now right for researchers to pick up esoteric topics, which also happen to be practical. How rarely does that happen, right? That establishing that channel, there are two things that happen. One, the people need to be there. The good news is they're there now. You have Mike Rose sitting here. You'll have Dick Cantwell. You have Tim Mill, right? You have Richard, that's why I'm back there, right? Lee Gillette, right? So you have people now willing to have these deep conversations, and they're very well equipped. What's missing is the medium, right? I think this is a great medium. I mean, I think we need to present research papers and have business guys go, that's pointless. But this I wish you would do. We're not doing that. And I think that applies to all of academia. So, yeah, Chris.
I've got another question. From a researcher's perspective, I think one of the challenges is that we all present in different research communities. Some human computer action folks, go to the HCI conferences, while as communication guys in RFID go somewhere. And every single time, or at least at this stage, we've got the problem that we get to motivate many of the problems that you mentioned. And very practical point, sometimes people in those communities are not very familiar with those special challenges of RFID. So do you think that in a couple of years' time we'll see a dedicated RFID conference that sort of covers a range, maybe not all, but a range of the issues you mentioned?
I think that might happen. So I think you're pointing at the deeper problem of systems design, right? And first of all, I think we have too many conferences in academic fields. They're too selective, and only those people go to those conferences. It's a very nice, cozy shelter where you don't really have to talk to the other guys, right? So I do think that an RFID conference, an RFID systems community will evolve. And maybe this is the start of it, which is why I congratulate everyone. But I think we also need to watch out that doesn't become an ultra-academic conference not connected to reality, which in itself becomes a kind of this mutant animal that no one's interested in. So we need to keep the end-user community involved. That's my view anyway. And that was kind of the success, as you remember, from the Auto ID Center. So, but I hope we can do that.
Thank you very much.
Thanks, Todd.
Thank you.